Okay, Bismillah. Let's see this exam problem. A smoking room with a volume of 500 meter cube. You know, you can see the smoking room when you go to the airport, where people could stand inside, or sometimes they could sit down inside so they could smoke. And of course, the main reason for this smoking room, that fresh air comes in and everything else inside the smoking room should be completely mixed, and dirty air coming out of the ventilation of the smoking room outside. The main reason for this smoking room is not to pollute the airport and to not let any smoking pollutant comes outside this smoking room. Okay, let's look at this exactly the same problem with that figure that we just showed you. Smoking room with a volume of 500 meter cube. So now we know the volume of this smoking room. It has 50 smokers. There is 50 people who are smoking inside the smoking room, each smoking 2 cigarettes per hour. An individual cigarettes emits, among other things, of course, not only this, but there is a lot of chemical that might come from cigarettes and smoking. And an individual cigarettes will emit 1.4 milligram of formaldehyde. Formaldehyde has this chemical structure. Of course, you don't see the carbon, but the carbon is in the center. There is one single space, one single bond with hydrogen, another single bond with hydrogen, and double bond with the oxygen. So it is the chemical structure of formaldehyde is like that. So formaldehyde converts to carbon dioxide, CO2, with a reaction rate of 0.4 per hour. The fresh air enters the room at a rate of 1,000 meter cubic per hour. This is how much fresh air is coming in. And the stale air leaves at the same rate. Polluted air is leaving at the same 1,000 meter cubic per air. Assuming complete mixing, this is what's going to make you think of CMFR. Remember the CMFR? Flow rate in, flow rate out. Let's say Q, and Q is the same. Let's say in and out is the same. And C, concentration in and concentration out. And there is complete mixing in the CMFR. And also the concentration, the instantaneous concentration of the pollutant inside the CMFR is C naught. So whatever N is, whatever will be leaving at the end of the reaction. This is the CMFR. When I see that there is fresh air entering the room at the rate of that much, 1,000 meter cubic per air, and still air leaves at the same rate, and assume complete mixing, I will assume it is a CMFR design, or a CMFR design equations. What's needed here, estimate the steady state concentration, and of course, look at this steady state concentration of formaldehyde in the air at 25 Celsius, 1 atmospheric of pressure. And how does the result compare with the threshold of eye irritation of 0.05 ppm? Is it higher than 0.05 ppm? Is it lower than 0.05 ppm? That's what we're going to show in the next few minutes. Okay, let's put the equation for the CMFR. Remember the equation V dC over dt is equal Q C initial minus Q C out final minus volume K C out. As he mentioned in the problem, it is steady state. So this is 0. So 0 is equal Q Ci minus Q C naught minus volume K C naught. He need to find out the steady state concentration of formaldehyde in the air. Okay? So he need to know what is exactly the inside the smoking room, and of course that's going to be the same as leaving the room. So he need to find out concentration C naught. So let's take C naught as a common factor. Let's take the QCI in one side and the other in the other side. So C naught Q. Okay, so you take one to the right and one to the left and take C naught as a common factor. So C naught is times Q plus volume K, and this would give you C naught QCI over Q plus volume K. So we know Q. So let's erase this. We know Q. Q is 1,000 meter cubic per hour here. And we know volume. Volume is 500 meter cubic. We know K is 0.4 per hour. What is needed right now? We know flow. We know this flow. But we don't know CI. He mentioned here, let's say that what is given, let's put it here. He just put it as 50 smokers, 50 people inside the smoking area. Let's say 50 people. Times each one of these people smoke 2 cigarettes per hour. Okay, that's right now 100 cigarettes per hour. And each cigarette will emit 1.4 milligram. So let's delete that. 1.4 milligram of formaldehyde per hour. Oh no, sorry, not per hour. He said that each individual cigarettes emit 1.4. So 1.4 milligram per cigarette. Because you have to cancel cigarette with cigarette. Now you'll end up with milligram per hour. So if you multiply 50 times 2, it's 100. 100 times 1.4, it is 140. So this would give you 140 milligram per hour. So now, remember from the class, we did mention that this is loading rate. When you multiply flow times concentration, this would give you loading rate. Sometimes you will have loading rate in and loading rate out. So this is loading rate in, because this is how many people they smoke, how many cigarettes per hour, and how many formaldehyde, what mass of formaldehyde per cigarette. This is loading in. This is how much is coming in from these 50 people who are smoking 2 cigarettes per hour, and every cigarette is emitting 1.4 milligram formaldehyde. So this means that this is equivalent to what? This is equivalent to QCI. This is a loading rate because it has mass. The loading rate is mass per time. Okay, so let's erase this so we could finish the CMFR parameters. So QCI is 140 milligram per hour. And Q is 1 meter cubic per hour. Plus volume is 500 meter cube. Times K is 0.4. per hour. And this would give you could cancel out hour with hour, and then you will end up with milligram per meter cube. So that will give you 0.117 milligram per meter cube. Okay, so now what is needed also is to find out if this 0.117 will meet the threshold of eye irritation. The threshold of eye irritation is 0.05 ppm. So we have to convert this to ppm. Of course, you should convert milligram to microgram. Remember the equation we have in class. It will convert if you have it in microgram. So 1 milligram is 1,000 milligram with milligram. You will end up with 117 microgram per meter cube. Let's go and look for the equation from the class. Microgram per meter cube is equal ppm times molecular weight times 1,000 times P atmospheric, 1 atmospheric, the pressure, divided by RT. R is given and T should be in Kelvin. Remember that T was 25, and of course pressure, 1 atmospheric. Okay, so 25, let's just put it here. Plus 273, and that is 298 Kelvin. So we have everything here. So let's apply the equation. What was the value? 117 in the left side equal ppm times the molecular weight of formaldehyde is 30. As you find it from the periodic table, times 1,000, and of course it's 1 atmospheric, divided by R is given as 0.08205. Temperature is 298. Let's look at my calculator and see, does it give you irritation or no? Let's look at it. So 1,000 divided by 0.08205 divided by 298 times 30, and then you take it to the other side, times 117, and this would give you the ppm as 0.095 ppm. This is the actual concentration of formaldehyde inside the room, 0.095. 0.095. Now, what was the threshold? 0.05. So 0.05 ppm is much lower than the actual concentration of the formaldehyde in the smoking room. It's almost doubled. So you can see that 0.095 is almost 0.1. And here it's 0.05. This is the guideline, the threshold for eye irritations. And for sure, the people inside will start scratching or itching their eyes. So 0.095 is nearly double the threshold of eye irritation. Thank you. Well, so some of the solutions that either they have to increase the volume of the air, the volume of the fresh air coming in, the volume rate, or increasing the area, or reducing the number of the people, and this will reduce of course, the problem with eye irritation. Of course, this volume has to be changed in the design. Of course, number of people entering should be also controlled. And of course, the fresh air coming in will be controlled in order to make it lower than 0.05. Thank you.